In the 2000s, I was integrating systems with SOAP and XML. Then in the 2010s, it became REST and JSON. And now in the 2020s, people want to use GraphQL and event streams. The technology has changed over the years, but the integration problems have stayed the same. After all this time connecting front ends to back ends to databases, I found the same principles work whether you're using jQuery or React, REST or GraphQL, MySQL or Postgres. Let me show you the patterns that transcend the framework of the month. Full stack integration isn't about protocols. It's about data flow and boundaries. And the principles that govern these concepts are timeless. They worked for Unix 50 years ago, and they'll work for your SaaS today. That's because the goals are the same. Build systems that are simple to understand, easy to debug, and possible to improve and evolve. And remember, these aren't rules, they're principles. So sometimes you just have to break them for a good reason, but it's important to know the reason they exist so you can be more confident when you do need to break them. The first principle is to start with the narrowest interface possible. The classic Unix commands that have existed forever, like cat and grep and ls, they do one thing and that's it, but they do them extremely well. Another example is HTTP. It originally just started with the get verb, just so you could pull down documents. So for a modern application, that means your API should be very simple when you first create it. It should have like a max of 5, 10 at the most endpoints for your API, and every endpoint in that API should do one thing clearly and well. You don't want to build in flexibility that you think you might need later when you don't need it now, because all you're doing is just adding in more complexity and expanding the scope beyond what you need it to be. So remember, don't create a universal API that can do everything. And don't start adding GraphQL just because you think, well, we might need flexible queries in the future. Instead, you just want to boil it down to exactly what you need and build that first. And the second principle is related. When it comes time to change your API, to change something about your application, versioning is more about relationships than the actual technology. The simple truth is you can't force people to upgrade unless you have control over the entire ecosystem. If you have a web application, sure, you control everything, but if at any point you're allowing customers to use your APIs directly, now you have to worry about versioning because any changes you make could potentially break their code as well. So when it comes to versioning, remember that backwards compatibility is a required feature if you have customers using the older versions. So have a strategy going into building your application around versioning from the beginning. From the start, embed versioning into your project. You want to be able to have the URLs themselves express what version they're using. Anytime you change the API, you want to make sure that it's either fully backwards compatible in your current version or create a new version, and then you're going to have to track how long you're keeping the older versions before you fully deprecate them out and get rid of them. And you want to make sure that you don't have customers still using the older versions. When it comes to APIs, remember, every version of an API is a contract, and you want to never violate that contract. Ultimately, you're versioning the contract you're giving to your customers that are directly using that API. The next principle is you want to make sure that invalid states in your application or your data are impossible to get to. This is a concept that's been around for over 50 years, and it's that good integration design will prevent errors at the boundaries between the different systems. So, for example, at the database level, you want to make sure you're using foreign keys effectively rather than relying just on application checks. Otherwise, you can end up with invalid data in the database, and that's going to affect everything after that point. In your application, in your backend, maybe you want to make sure that you're using required fields, validation, etc. This way, your front end isn't going to be the only one doing all that validation checks. In a front end, you want to make sure that you're using, let's say if you're using TypeScript, you want to use like discriminated unions. This way, you're not just having nullable fields that could accidentally pass down data that is not valid. A real world example of this is if you're tracking a user's order in your system, and a bad example would be using Boolean variables to track the different steps they have to go through. So for instance, if they've paid, that's one Boolean. If they've shipped, that's another Boolean. And if it's delivered, as a third Boolean. The problem here is you can end up in a situation where someone accidentally set, let's say delivered is true, but it was neither paid for nor shipped. Is that a valid state? No, of course not. Instead, you should be tracking the user's state, since you can treat that as a state machine. So now you have a status field that says that they've paid, they've shipped, they've delivered, and you can know that based on what the flag is, what that status field is, you know exactly where they are in the flow, and it's not possible to get into an invalid state with the rest of your data. The payoffs here are huge. You have significantly less bugs. You don't have to worry about defensive coding as much because you don't have to worry about those cases that are invalid. New developers that start working on the code understand immediately what's happening, and even for you yourself, you go back to the code in 6 months, you're going to be able to remember what you did there. Moving on to the next principle, and that is idempotency is non-negotiable. The simple truth is networks are going to fail. People are going to double click a link. Browsers sometimes just randomly refresh. You want to make sure that whatever request is being sent over and handled by your application, it always ends up in the state you want it to by only doing something once. So this concept of idempotency, it's not something fancy you should consider adding to your application. It should be fundamental. So what this means for your application, you should be preferring puts, or in other words, like upserts, over posts or just plain inserts. Whenever you accept critical new data, you want to have some sort of idempotency key in there so you know you're not duplicating it by accident. And anytime you're handling events, you want to make sure those events are handled at least once, but with deduplication so you don't handle them multiple times. A good rule of thumb is, can this operation be retried safely? If not, then it probably needs to be redesigned. The fifth timeless principle for full stack integration is that you want to optimize for debuggability. If there's any optimization you can do, it should be for being able to debug how things are handed off between the different parts of your system. The sad truth is you're probably going to be spending more time debugging your code than actually writing it, especially if a bug comes in. And so therefore, observable systems are maintainable systems. And simplicity here beats complex systems all the time. Tactically, this means it'd be great to have correlation ID. So if you do have multiple parts of your system, say a front end and a back end, you have an ID that can tie the initial session from the front end over to the back end. You also want to have structured logging, so JSON logs as opposed to just raw text, because nowadays most systems where the logs go to will be able to actually parse the JSON and provide better search functionality that way. Anytime your system returns an error to either the front end or to a user or to anywhere, you should have clear error messages either in your logs or in the actual responses back. This way you can debug from that error message and going forward. You don't want to just have like, error 404 or error 401. Ideally, there would be an additional message that indicates what caused that problem. So you can at least start by looking in the code base where that error message is thrown from. And of course, make sure that your logs are actually going somewhere you can view them. It doesn't do any good if the logs just disappear into the ether and you can never view them anymore. One additional benefit to good logging in your code, it actually kind of acts like good comments as well. It's pretty common for me to skip comments around areas where I have good logging because the logs themselves inside the code let people know what's happening there. So all of these principles are timeless because they address human problems and not technical ones. For instance, the reason we want to have narrow interfaces is because humans can't hold complex systems in their head as well. You want to have versioning because humans tend to resist change. We avoid invalid states because humans make mistakes, and that's true for both users and the way we write code as well. Idempotency? That's because humans double click. And debuggability is because humans need to understand what happened. Remember, technology will change, but these problems won't. Which principle would fix your current integration headache? Let me know in the comments below. And subscribe if you believe in boring technology that actually works. Thanks for watching. I'll see you next time.